So if we want to graph the function y is equal to the square root of x minus 1, one of the strategies that we can use to do this is by plotting some points, right? So we can, or an easy way to do this is often to make a chart, right, with our x values on one side, our y values on the other, and to pick some values here. Let's say -1, 0, 1, 2, 3, 4, and plug those in for our function and see what we get for y, plot those points on the curve. So that's what we're going to do here. So if we start with -1, for example, and we try to plug that in for our square root function, we'll have -1 minus 1, which is -2. We don't know yet how to take square roots of negative numbers. So for now, this will just be undefined, which means we don't plot a point for it on our graph. Okay, same thing with 0. 0 minus 1 is -1. We don't yet know how to take the square root of a negative number, so this is also undefined, which means it will not show up on our graph. But once we get to 1, 1 minus 1 is 0. The square root of 0 is 0. So we've got a point here at 1, 0 that we can go ahead and plot on our curve, or on our graph. So if we have an x coordinate of 1 and a y coordinate of 0, that's going to go right there. And then we can continue from here, right? 2 minus 1 is 1, the square root of 1 is 1. 3 minus 1 is 2, so we'll have the square root of 2, which is approximately equal to 1.4 something. And then we'll have 4 minus 1, which is 3, the square root of 3, which will be approximately equal to 1.7 something. And 5 minus 1 is 4, the square root of 4 is 2. So we can go ahead and plot all of these points along our curve. We've got 2, 1, over 2, up 1. We've got 3, 1.4-ish, so somewhere in here. We've got 4, 1.7-ish, so somewhere in here. And then we've got 5, 2. So once we have done this, we can really start to see the shape of our curve. And after doing a lot of practice, we'll start to remember in general what a square root function looks like, and in general what a quadratic function looks like, or a cubic polynomial, or a logarithmic, or whatever it is that we work with during this class. The more we practice with them, the more we'll start to know, and then we can just use the points that we have to fill in the rest of the general shape like this. Now, one other point that I'd like to make is with these estimates here of 1.4, 1.7, you don't need a calculator to do those. Again, with a lot of practice and after you've done this for a while, you'll start to just remember, okay, square root of 2 is equal to 1.4 and square root of 3 is about equal to 1.7. But even if that was not the case, you could still approximately figure it out because you know, like the square root of 4, for example, is 2, and the square root of 1 is 1. So the square root of 2 and the square root of 3 have to fall somewhere in between there. So you can make reasonable assumptions, reasonable guesses for where that could be to plot it on the graph, even if you didn't know. But the other thing you could also do is just pick some values that might fit into this a little bit better. So for example, a number like 5, where 5 minus 1 is 4, and 4 being a complete square, or a squared number, is going to end in an integer when we take the square root. Same thing with something like 10, right? 10 minus 1 is 9. When we take the square root of 9, we get 3, which is also an integer. So you could kind of do it in either way like that if you're unsure for something specific, like a square root at least. But even without a calculator, you can get pretty reasonable estimations for things like this if you just take a minute to kind of think about what it might be as far as how to plot it on this.